3t squared. The next case is acceleration. Acceleration is dv over dt. Now this will give us 5 plus 3t squared will give us 0, plus if you differentiate 3t squared, that will give us what? 6t. Alright, that will give us 6t. So our acceleration is 6t. Now at the end of the day, at 3 seconds, so when t is 3 seconds, acceleration now will be 6 bracket 3, which is 18. So the correct answer is 18. The option is there, but it was written with a pen, so you should know that that is the correct answer. The option was written with a pen, is there, so maybe they did a correction. 18 is the correct answer. Now evaluate the antiderivative. Now antiderivative is quite different from derivative. Is that okay? When they say evaluate the antiderivative of anything, it means the of the something. All right. Antiderivative means the integral. So when they say differentiate, integrate, find the antiderivative of sine 3x. Now it means you should find the integral of sine 3x dx. Now in integration, what you do first of all is to differentiate this sine 3x. You know, in integration you differentiate in integration also, but in differentiation you don't integrate. That is one. Methods of differentiation often, methods of integration often involve some differentiation. That is why you learn differentiation before integration. So this one now, what you are going to do is you integrate sine, you differentiate 3x. Now whenever you differentiate 3x, it's going to give us 3. So now integrate sine is going to give us minus cos. So you write minus cos 3x. Remember that you differentiated 3x to give us what? 3 plus c. So this is the correct answer to this question. Minus cos 3x divided by 3 plus c. In integration, you always add plus c to it. So this is the best way to go about this question. First of all, differentiate this 3s. You know that will be on your denominator. Then integrate sine. We're going to give us cos, minus cos. Then of course you have your 3s divided by 3. You know, in differentiation, what we did was, if you have sine 3s, you differentiate this 3s to give us 3. Then differentiate sine to give us what? Cos. And then you write 3s. But this one now, the only difference is you integrate. When you integrate sine, it's going to give us minus cos 3s. Instead of you multiplying this 3 here, all you now do is to divide it. That's what we did here. So this one gave us minus cos 3s divided by 3 plus c. Very simple, right? Now the expression for this is, now in the exam, whenever you see something like this, the correct answer is ax divided by a ln, or let's say a raised to the power of x divided by natural log of what? A plus c. If they say you should integrate this. Alright, so any integral that was given to you, you should use this approach to solve it. So if they say integrate 7x dx, first of all write the 7s, then write natural log of what? 7. And that is the correct answer to that question. Is that okay? Exactly. So now integrate this. Now whenever they gave you something like this to integrate, what you do is, you know, in differentiation we are going to differentiate 5s and use it to multiply this. But in integration, what you do is write the e raised to the power of 15x again, divided by, differentiate 15s, or divided by whatever you have here, so plus c. This is the correct answer to that question. All these ones are shortcut I'm teaching you so that you not waste time in the exam. Or so if they give you anything like e raised to the power of 4x, integrate. Remember the difference between integration and differentiation. This one will give us what? E raised to the power of 4s divided by 4 However, if it is differentiation, it will be what? 4e raised to the power of 4s. The difference is one is multiplying, the other one is what? Dividing. Is that okay? Exactly. So that is the correct answer to that question, and that is option A. Option A for this particular question. Now let's see the next one. Evaluate this. Now whenever they give you any question like this to evaluate, there's no shortcut to this one. You have to solve it yourself. Now, how do you go about something like this? Let me teach you how to go about something like this. Now, the first thing you do is you say let u be equals to everything in the bracket. So u will be equals to s squared plus 1. So it means your du dx is equals to what? When you differentiate this, it's going to give us 2x, right? So that your dx now cross multiply. Are you getting it? When you cross multiply, du will be what? 2s dx. Is that okay? Du will be equal to 2s dx. So that your dx will be what? Your dx will be du all over 2x. So that is the approach you need to know. Now, recall that you said your integral is this. So, integral x, we said let everything in this bracket be u, right? So we can say here will be the square, the square will be u. Here will be square root of u. And then here is what? Dx. But you say your dx, you've calculated your dx to be what? Du over 2x. So here it's going to be x root of u times du over 2x. And then this cancel x. And then what are you left with? Integral of u du divided by what? 2. Are you getting it? Because this du is divided by 2. Now these 2 can come out as a constant. So you have half integral root u du. Here will be half. Now integral root u is written as half. So here will be half. Now when you integrate this, it's going to give us u. You add 1 to the power according to integration divided by whatever you have here, which is half plus 1. So that at the end of the day, here will give us half u. Half plus 1 will give us 3 over 2 divided by half plus 1 will give us 3 over 2. Cos is plus c. Alright, exactly. So that at the end of the day, now what do you think we can actually do here? This value you have here can come down here, and when it is coming down, these two will go, no. All right, so you have half u 3 over 2 then divided by, that is the meaning of this, 3 divided by 2. All right, now at the end of the day, what do you think we can actually do here? Now if you remove this division sign, here will become multiplication. 2 will come up, 3 will come down. So here will be half u 3 over 2 times 2 over 3. Now, at this point in time, these 2 can cancel these 2. So what are you left with? You are left with 1 here. So here will be 1 over 3 u 3 over 2 plus c. Alright, exactly. Now, at this point in time, what you are now going to do is to plug in what you said your u should be earlier. Now recall that we said our u should be s squared plus 1. Look at it here. U should be s squared plus 1. So plug that into this equation. Let me just put it here for the final answer. So here will be 1 over 3. Wherever you see u, put s squared plus 1, then 3 over 2 plus c. And that is the correct answer to that question, which is option A. Alright? Option A. Now, the next one says evaluate this. This one is kind of very easy, right? When you integrate something like this, it gives us s raised to the power of 3 divided by 3 minus 2. Then integrate this, give us s squared divided by 2 plus what? 8s plus c. These two cancels these two. You have s raised to the power of 3 divided by 3 minus s squared plus 8s plus c. Alright? And that is the correct answer to that question. Now, I think what I'm seeing here is 5 and not 3. It's like it's 5 and not 3. So, maybe 5, it may be 3. Whichever one we are seeing here. If here is 4, it means here will be 5, 5, 5, 5. But whichever case, the correct option here is option B. It's not that clear. Alright? But you should know the approach to solving it. That is the most important thing. Now you have all over 2x. So you have du over 2x. And then this cancels this. What do you think you are going to have? You are going to have integral of 3 over u times the u over 2. Take this 3 out, 3. Take this 2 out, 2. So you have integral. What will be left here? 1 over u du. Now, integral of 1 over u is the natural logarithm of u, absolute value of u, plus c. So 3 over 2, and then u is what? S squared plus 2 plus c. And that is the correct answer. You see how easy calculus is. All these things are things I learned, like, cannot remember again. No. I learned all this stuff about 8 years ago, 9 years ago, but I can still remember them vividly. Alright, even when I'm not in that line again. Alright, so that is basically how to go about a question like that. And the correct answer to that question is option A. 3 over 2, natural logarithm of s squared plus 2 plus c. Option A. Alright, let's see the next one. Integral of 7s ds. Now, I told you that whenever you have something like this, integral of a raised to the power of x, told you that this is what? A raised to the power of s, natural logarithm of a. Now, in this case, the reason why it is like this is because the power here is x. When you differentiate x, is going to give us 1. So this is supposed to be 1 natural logarithm of a, but you cannot put 1 here because anything multiplied by 1 is still that same thing. Is that okay? So in this case now, you say this is 7 raised to the power of 3s ds. If you integrate this, first of all, write the 7 raised to the power of 3x divided by, when you differentiate this 3x, it's going to give us 3 and not 1. So you have to indicate the 3. And then you now have natural logarithm of the 7 here. So this is the correct answer to that question, which is 7 raised to the power of 3x divided by 3 natural logarithm of 7 plus c. And that is the correct answer to that question. Alright, let's see the next one. You have this one says evaluate sine square s cos x dx. Now, how do you solve this kind of question? It's kind of very easy, but at the same time, it requires you to think. Alright? It requires you to think. So, what do you think we can actually do here? What do you think we can do here? Let u be equals to cos x dx. Is it possible like that? If we say let u be equals to cos x dx, if you differentiate u, it's going to give us the what about no, that will not work. That might work. All right.